Hands. They are such a basic part of our lives. We use them every day even without thinking. But for generative AI, they have been the ultimate challenge. AI can create hyper-realistic faces, jaw-dropping landscapes, and even mimic the brushstrokes of famous artists. But when it comes to hands, things get weird. Honestly, it's not just AI. Hands have been giving artists headache for centuries. I mean, who hasn't heard an artist say, just put the hands in pockets or let's hide them behind something? Even AI took that advice to heart. Literally, as a person hilariously put it on Twitter, never ask a woman her age or an AI model why they're hiding their hands. To understand why AI struggle with hands, we need to rewind the clock. Generative AI didn't just appear out of nowhere. It all started back in the early 2010s with basic model like generative adversarial networks. These were the first tool that could create images, video and audio that seem authentic recording of real people. But the real leap came around 2022 when tools like Midjourney, DALL-E and Stable Diffusion hit the scene. Suddenly, AI could create art that left people in awe. I mean, think about it. What used to take hours of sketching and painting now could be done in seconds. I still remember the first time I tried AI art. I was 17, just a high school student messing around with Midjourney. I wanted to see how it will render some cool pictures, and let me tell you, it was wild. AI nailed everything, the lighting, the textures. But when it comes to hands, let's just say, it gave more fingers than a person actually signed up for. But I am not 17 anymore and it's 25 now. Times have changed and so has AI. Just look at this. Isn't it amazing? Okay, may not be perfect, but come on, how can you complain about this progress? Today, we are diving into the story behind this transformation. But before we dive into the success story of AI and its progress, let's take a step back and really understand why hand were such a tough challenge in the first place. I mean, sure, AI can generate some cool, pretty impressive stuff now, but let's break down what makes hands so difficult to get right. The complexity of hands. Hands are incredibly complex. They have 27 bones, numerous joints and can move in countless ways. Imagine trying to draw something that has this much moving around inside it and you can't even see most of it. That's the challenge of AI. Unlike other objects, hands move in a way that can look completely different depending on how they are positioned. A fist looks completely different from an open hand, and if you add in fingers, curling or interacting with something, it gets even trickier. Example, picture yourself trying to draw a hand that's holding a cup of coffee. The way the finger wraps around the handle, the angle at which the wrist bends, and how the palm curves, all these things change how the hand looks. For AI, it's like trying to guess all these changes with only few clues. Variability in hand shapes and size. Hands are not all the same. You have got tiny hands, big hands, long fingers, short fingers, and don't even get me started on how hands change based on the person's age, gender or ethnicity. AI models need to learn to generate all this variation accurately. Factors such as age, gender, ethnicity, and even hand postures significantly influence the appearances of hand, making it a nightmare for AI to replicate them accurately. Early struggle, lack of quality data. AI models in the past struggled because they didn't have enough data to learn from. It's like trying to learn to draw hands without even seeing a hand in real life. Early models were mostly trained on 2D images, so they didn't understand the full 3D shape of hands. Most dataset focuses on faces, landscapes, and common objects, with very few dedicated to hands. Even the available data had limited variety in terms of hand poses, shapes, and interaction with objects. This caused a lot of weird twisted fingers per hand that just didn't look right. So what changed? How did AI go from a meme-worthy struggle to creating hands that are almost spot on? Let's break it down. Well, things started to look up with the rise of generative adversarial networks and diffusion models. These are like super smart artists that can generate more realistic images by learning from huge dataset of hands. Generative adversarial networks work through a creative back and forth game between two neural networks, the generator and the discriminator. The generator, think of this as the artist. It creates images from scratch. The discriminator, this is a critic. It checks whether the image look real or fake. The two networks are constantly trying to outsmart each other in a process similar to game of real versus fake. The generator gets better at creating more realistic images while the discriminator becomes better at spotting fakes. This rivalry pushes both networks to improve, resulting in images that eventually look indistinguishable from real ones. Example, if you were an artist trying to draw a hand, but every time you make a mistake, a judge told you exactly what was wrong, you will get better, right? That's how generative adversarial networks work. While generative adversarial network made a huge impact, diffusion models represent the next generation of generative models. Unlike GANs, which rely on adversarial training, diffusion models take a completely different approach inspired by thermodynamics. Here's how they work: forward process and reverse process. Forward process, the model gradually adds noise to an image until it's completely distorted. Imagine taking a perfectly clear photo and turning into static. Reverse process. The magic happens when the model learns to how to reverse this process step by step, transforming the noisy image back into a clean, high quality image. This process allows diffusion model to generate image with greater stability and diversity than GANs. They are particularly good at capturing fine details like the curve of fingers, shadow between knuckles, and subtle texture of skin. Example, with diffusion models like stable diffusion and denoise diffusion probabilistic model, AI can create hyperrealistic hand from scratch, maintaining consistency across multiple angles and even generating hands in complex poses. In short, the rise of generative adversarial network and diffusion models has taken AI image generation to next height. They have turned what was once a meme-worthy struggle into a field of incredible innovation, bringing us even closer to perfect AI-generated hands. The power of neural rendering. Here's where things get truly next level. Neural radiance field, NeRF. If GANs and diffusion model are talented 2D artists, NeRF is a magician that brings images to life in 3D. Unlike traditional AI model that only work with flat 2D images, NeRF builds 3D representation that allows AI to understand objects like hand from every angle. Here's how it works. NeRF take a bunch of 2D images of same object like hand from different viewpoints and magically transform them into detailed 3D model. This model then can be rotated and viewed from every angle, providing a consistent and realistic representation. Think of it as a AI learning to see in full 3D rather than just guessing what things look from different sides. Imagine trying to generate a high five from two different perspectives, one facing the palm and another facing the side. Without 3D understanding, AI might make the finger look unnaturally thick or blend them in different weird ways. But with NeRF, AI can maintain consistent proportions and depth across both views, creating a hand that looks natural in 3D shape. NeRF's ability to rendering photorealistic 3D models has revolutionized the way AI understands complex objects. Combined with diffusion models and GANs, NeRF pushes AI-generated hand closer to perfection by making them real from every angle and interaction. The current state, still a work in progress. Despite all the breakthrough with GANs, diffusion models, and neural rendering, AI still has a long way to go when it comes to perfectly generated hands. Sure, the model have gotten better, but they still struggle with things like lighting, shadow, and complex interaction between hands and objects. AI sometimes makes hand look like they are from another planet, especially when there are too many fingers or the hand is holding something complicated. Conclusion. So, in 2025, while AI has made huge strides in generating realistic hands, there's still a lot of work to do. It's not just about creating hands, it's about understanding how it moves, interacts, and look in different lighting. But as we continue to push the boundary of AI with models like GANs, diffusion models, and tools like NeRF, the dream of perfectly realistic AI hand might just be within reach. Hands symbolize creativity, connection, and the capability to transform idea into reality. As we improve AI, we are not just perfecting images, we are also learning to understand and appreciate the intricate dance of universe through something such as simple as hand. It's a testament to the endless possibility of technology and the underlying curiosity of human spirit. Thanks for joining me in this deep dive into AI hands. I hope you found it as fascinating as I did. Catch you in the next video.